My lead said, not today. Oh, but for real, might be out of lead. I'm gonna do this in red pen. It's gonna be crazy. Okay. So y equals cos inverse of 3x squared. Okay. Now what do we do? Okay. So cos y equals 3x squared. What's the derivative of cos y? And then what's the derivative of the right side? Okay. And then what should we be doing at the same side? Or at the same time, I mean. Drawing anything? Oh, is that hurting your eyes at all, or are you good? Hold on, let me take off. Okay, so we've got our right triangle, and what should I label in the right triangle? So I've got cos of the angle y, and then what else do I have? Cos y equals, so adjacent over hypotenuse. And this side could be A or B, it doesn't matter. Go ahead and call it B. Okay. So I've got A squared plus B squared equals C squared. And I'm solving for the third side. Okay. Okay. Comfortable with that? Okay. So we've done this work over here. Let's go ahead and keep doing this work. So you guys had said something, I had kind of ignored you as I was finishing the triangle over here. Divide by negative sine y, and what's the purpose of doing that? To isolate the derivative, so we have 6x over negative sine y, and that's getting the dy dx all alone. Okay. I'm going to go ahead and move the negative up to the top, so I'll do dy dx equals negative 6x over sine y. And then what am I going to do with the sine y? Yeah, it's going to be opposite over hypotenuse. So sine y equals opposite over hypotenuse based on this triangle. And if we use this triangle, what's opposite over hypotenuse? opposite over hypotenuse. We don't really need the 1. So we can say dy dx equals negative 6x over square root of 1 minus 9x to the 4th. Okay. Now, if you want to look at the shortcut for that, the shortcut for this says that if your angle is x, then this is the shortcut. You have negative 1 over the square root of 1 minus the angle squared. And we know that we always have to do the chain rule. So what you would do if your angle was 3x squared is you'd have the negative version. You'd have 1 minus the angle squared, which we did have because 3x squared squared is where the 9x to the 4th came from. And then when you multiply by the derivative of 3x squared, because you're doing your chain rule, that's where the 6x came from. So yes, is the shortcut easier? Absolutely, if you can remember the shortcut. Does that make sense? Okay. So you guys are welcome to, but if you see these shortcuts, they're all fairly similar, but all slightly different. This is, if you look at these shortcuts, this is why I did not just give you the shortcuts in a video. Are they easy to use? Yes. Are they hard to memorize? It kind of depends how you are at memorizing. Does that make sense? Okay. All right, do you want to practice another one? Okay, so number 4, I threw in there to mess with you. Tell me why number 4 is not difficult. It's a regular problem. It is not inverse trig. It's just regular trig quotient rule. You see that? So number 4 is just normal. Number 4 is not anything strange. I just put it on the worksheet so that you wouldn't forget how to do normal trig stuff like you've done in the past. That is if you're doing a limit, the limit as x goes to 0. But it's not a limit. Yeah, and this is just, it just says find the derivative of this. So this is just quotient rule, low d high minus high d low. Yeah. Okay. Now all these are just regular derivatives. I think somewhere, yeah, if we look over here, like number 9, we've got sine inverse of a sine, which is kind of interesting. Number 12, we've got secant inverse of an ln. That's kind of interesting. Number 11, we've got a chain rule in there. That's, or a product rule, I mean. That's kind of interesting. So what would you guys like to do? Do you want to do another one? Do you feel like you're ready to do some on your own? We can do 12. Okay. So how do we start it off? All right, so what do we do first? So we get secant y equals 3 ln x. Draw a triangle. So here's our angle y. So secant is the opposite of cos. It'd be 1 over, so it's hypotenuse over adjacent. So the 3 ln x is which side? Hypotenuse. 3 ln x over adjacent. Mm-hmm. 9 ln x squared minus 1. So the way that they would write it is they'd say 9 ln squared x. That way that we can avoid writing parentheses. Kind of like sine squared x or cos squared x. 9 ln squared x minus 1. And then, so what is b? And then notice I didn't say, oh, 9 is a perfect square, so I can square root it. I'd be killing a kitten if I did that because of the minus right there. Okay, so I'm not killing any kittens today. Mm-hmm. Okay, so my triangle is all set. Okay, now what do I do? So I do my derivative. What's the derivative of secant y? Secant y tan y dy dx. You don't have to put it with each one because it's not like you did 2 derivatives. You did 1 derivative. That 1 derivative happens to have 2 terms, basically. Or like it's 1 term really, but it has two trig things. Secant y tan y dy dx. And then what's the derivative of 3 ln x? Say it again. Mm-hmm. So we know the derivative of ln x is 1 over x. We have a coefficient of 3. We know that coefficient always just hangs out. So 3 times 1 over x is where we got the 3 over x. Okay. Okay. Mm-hmm. Uh-huh. Yeah. Okay. So we know that secant y is 3 ln x because we already had it. We had it right here. So we just have to know what tan y is. So secant y is 3 ln x. That's from the original problem. What is tan y? Opposite over adjacent, which is? So we have dy dx equals 3 on the top, x on the bottom, And then we have 3 ln x. That's the secant y. And then that whole square root. 9 ln squared x minus 1. You can simplify the 3's, get rid of them. And I ran out of room, so I'm going to leave it there, but you could rewrite it with having those 3's cleaned up. That's about it. You can't do x squared because this x is like a GCF kind, or not a GCF, but it's in front, and that x is ln of x. Right. Brains are okay. Whew. That was so fun. Wasn't that so fun? Ooh, I liked that. Okay, so let's look at the shortcut for that one. So that one said, whatever the angle was gets put in front of the square root sign. So that's why we had a 3 ln x in front of the square root sign. It says that you'd have the angle inside squared. That's where the 9 ln x squared came in. And then we always have to do the chain rule. And so that's where the 3 over x came in. Does that make sense? So we had the x in the front, that's the 3 ln x. We had the x squared, that was the 9 ln x squared. And then the 3 over x was from the chain rule. So we did have our shortcut in there, yeah. This 3 ln x was from this x right here for the shortcut. The 9 ln x squared was the x squared right there from the shortcut. The 3 over x was because we would have done a chain rule, right? We would have done keep the inside the same, multiply by the derivative of the inside. As we did this because our inside function was 3 ln x. So as we did this problem, we would have had to multiply by the derivative of the inside, and we know the derivative of the inside was that 3 over x. And so that's where we got that 3 on the top, x on the bottom, the 3 over x. So that's where all those pieces came from if we had done that shortcut instead of doing it the long way. All right. So if you want to switch over to using the shortcuts, I will not judge you. It certainly is quicker. I think it could be a little bit dangerous. I would say certainly do flashcards for that. I would definitely put the shortcuts. I mean, you're going to have your cheat sheets on a test, but I'd say maybe definitely put them on a cheat sheet. Well, I mean, you have the yellow sheet. I'd say definitely practice them if you think that you might try to use the shortcuts. But I think that this method works because you're basically learning one method that works for all 6 of them, which is, and it's familiar because you're using the idea of SOHCAHTOA, which you've done before, as opposed to learning the 6 different rules, which is why I think that I've kind of committed to teaching it this way. Okay. All right, go ahead and get started. I'll go ahead and put the answer key on the back. So you guys can refer to it if you need to. And then I'm going to work on grading your quizzes. Sound good? Yes. Cosecant is opposite of sine, yes.